Hello, everybody, and welcome back to the channel. Today, I have another SQL tutorial for you. We're going to take another look at the information underscore schema metadata catalog. This is a direct follow-up to the previous video where we started talking about this metadata catalog, and we took a look at a particular table called information underscore schema dot columns, and we took a look at how you can quickly retrieve the data types of all of your columns in all of the tables in your database using that particular table. So if you haven't caught that video, I highly recommend that you take a look at it. I will post a link below so you can check it out. And if you are new to the channel, I post SQL, Python, and Tableau tutorials. I've been focusing on SQL lately, but I like to cover all those three. And I post videos on YouTube under this channel name called New Angle Analytics, but sometimes I also post content on Instagram. The handle is a little different there, and it's called Data Journey with Alper, Alper. So if you're interested, make sure that you subscribe to this channel on YouTube, and you can also follow me on Instagram. Anyway, let's jump back into our topic. In the previous video, we took a look at this table called information underscore schema dot columns. So if I bring that up, you'll probably remember that it contains a lot of metadata information about my tables. And in this particular case, we were looking at the data type, and we did some, tweaking to this table to get it to come a lot cleaner. And then we got the information that we wanted. Today, we're going to focus on a different business question. What if you took over from somebody else and you have this database that you're dealing with, and you want to understand whether certain columns have constraints on them or not? And if there are constraints on them, what exactly are they? Which is the primary key in a particular table? Are there any foreign keys? Do you have any unique constraints implemented on a column? There's a fairly simple way to get that information, and you use this exact same metadata catalog. You can use information underscore schema. We just need to tweak it a little bit. So today we're going to talk about that. So let's get started. So obviously I'm not going to use information underscore schema dot columns. Instead, I will going to use information underscore schema, and I'm going to go to table constraints. So as you can tell, I'm still in the same metadata catalog. I'm just referencing a different table. Let's take a look at what it typically stores, and then we're going to clean it up a little bit. Now, this particular table is a lot smaller than the columns table. It doesn't have that many columns, but it does include some critical information. As you can see, I've got this column named constraint name. It does include some constraint information, like obviously PK stands for primary key and FK is foreign key. And then SQL itself creates a unique identifier. And this column is going to be important when we do some joins later in the video. But you have a cleaner version of that in this column right here called constraint type. As you can see, I can tell primary key. I can see whether, the database owner wants the column to have unique values or not. So I can tell, all of that just by looking at this table. But I would, of course, want this to be a little bit cleaner. I've got some columns that are not really relevant for our discussion here. So let's go ahead and clean this up a little bit. Okay, so let's get, I want the constraint name, I want the table name, and of course, I want the constraint type. And then you might remember something that we did last time where we don't want the table schema to have any system table values. We just want those tables that were created by the database owner. Now, in my example, the only results I get are DBO, which stands for database owner anyway, but you may have cases where that may not necessarily be the case. So it's important that you get used to preparing your query in this manner, and you're prepared for any outcome, especially if you're taking over from somebody else and you're not really familiar yet with the database. It's always better to filter some system results out and only deal with those tables that were created by the database owner. So if I do this and run this, this will of course run, and give me a much cleaner table now. So now I can tell the unique constraint name, I see the table name, and I see the constraint type. But what's missing here? Some information is missing, right? When we started the video, we said the business question is we want to understand which columns may have constraints on them and what those constraints might be. But I don't see any information about column names. I can't tell what the column titles are. I can just see that the albums table has a primary key, but I have no idea what that column is called. That's because this particular table doesn't have that information, but we could easily create a join and get that information. Now, I know if you watched the previous video, you are probably thinking, can we use the columns table? We saw that one before. We're familiar with that table. I do want to show that. Let's do the join there first. I don't recommend doing it that way, and I'll show you why, but it is important to start there, and we'll work our way from there, okay? So let's say that I'm actually going to keep this query, and we can work with this. So let's call this table constraints. Let's give it an identifier as TC, and then let's do an inner join with our previously discussed table, which is columns. I'm going to call that C, and obviously we got to join them on table name, but that's not enough. Now it's important to create a secondary line here and make sure that you also join this with table schema, because you may have the same table name under different schemas. So if you omit that information, you're going to get inaccurate results. So make sure that you also match your table schemas. Imagine a case where you have a table called products, but you have one products table under one schema, but then you have a temporary table under staging or something, and under the staging table schema, where you're just testing some results. You're just testing some data flow, but the table names are the same. It's products. So if you don't include table schema, you're going to run into issues like that, where the table name might be the same, but the schemas might be different. So in order to avoid that, just make sure you add that secondary line. I'm going to keep that. Now, obviously, SQL is going to complain that table name is ambiguous because both tables include that. So let's do tc dot table name. And then let's see if this runs. Up table schema is also ambiguous. Let's do the same thing. And then let's run this. Okay, so this ran just fine. And all I did is basically I took the table constraints table that we just looked at, and I joined it with the columns table that we previously looked at, because the columns table does have a reference to the column name, which actually reminds me that we forgot um, a very important column, which is the column name. That's the whole reason we're doing this join. So I forgot to add that to my select statement. But now that we added it, let's run this again. And now, as you can tell, the join happened, it works, and now I have my column name. It's no longer missing. So I have the constraint type, I have the column name, I have the table name, and I'm filtering out the systems tables. There is a problem here. This is not the right way to get this information. Can you tell what the issue is? When I look at this, for example, let's take a look at the albums table, okay? Albums table has 6 columns total. But when I look at this particular result, if I select all the entries that have the table name albums, I'm seeing 18 cells, meaning 18 results. But the albums table only has 6 columns to begin with. So how could I possibly be getting 18 different results? And if I look here, this suggests that the album table has 6 primary keys, but that makes no sense. As the database owner, I know for a fact that I only created one primary key, but realistically, you're not really going to have in a table that has six columns, you're not going to create six primary keys, obviously. So what is happening here? Well, the issue is that the columns table, it just stores every column in your tables, whether or not those columns have constraints, right? So it doesn't really matter to the columns table that your particular column has any constraints or not. It's just going to store that information. What SQL is doing is it's taking table name and table schema. So, let's say that it's looking at table schema DBO and table name albums. As long as DBO and albums are matching, to the other table, it's just going to match the constraint type to that. So you're seeing primary key, primary key, primary key repeated here. So SQL is doing the matching correctly, but it's basically saying, okay, DBO albums, I have that result across both of the tables, and the joining result in the constraint type table is a primary key. But by the same logic, this is also DBO albums, this is also DBO albums, this is also DBO albums. The way the join is happening, you're getting the constraint type repeated. So this really won't be helpful to you because it will actually give you inaccurate result and it will be super confusing. For example, release date certainly is not the primary key. In order to get to the accurate result, what you're trying to achieve, we're going to have to use a different table. I just wanted to start here because we already know the columns table and I wanted to show you why it's not a good idea to use this particular table to get the information you're looking for. So luckily, we do have a solution. We just need to change our join statement a little bit. Okay, so in order to do that, let's remove the select statement. I'm going to leave it empty for right now, and I'm going to get rid of these lines, and I'm going to change what table I'm going to reference in the metadata catalog to join with my table constraints table. And that table is called key column usage. For short, let's call it KCU to do our joins. Because I'm using a different table, I can actually do the join on something different, which is called constraint name. I can actually reference constraint name across both of the tables. So let's go ahead and do, oops, not column name, but constraint name. And of course, don't forget to include the table schema because the same idea applies, right? You might have the same constraint name across different schemas. So you want to make sure that you account for those. I'm going to leave the where statement as is, and then we'll add an order clause in the end. But first, let's figure out what we want to see from here. Okay, so I want the table name, I want the constraint name, and I want the constraint type, all from the table constraints table. I need the column name. Let's put it here, but now I'm going to get the column name from a different table. I'm not going to get it from the columns table. I'm going to get it from the key column usage table. Um, let's do this. And let's see if I'm running into any issues. Let's see if SQL is angry with me or not. Looks okay. I've got my column name. And then let's order this by um, table name. It's just a little bit easier to read. So let's run this and I'll show you why this gives us a better result. Now, as you can tell, I'm only getting 17 rows now. This makes a lot more sense because key column usage is only storing information about those columns that do have a constraint on them. So all the other columns that don't necessarily have anything implemented, it doesn't even include that. So when I'm doing my inner join, the join already takes care of all the irrelevant results. So as you can see here, look at the albums table. Only two results. Out of the six columns, I'm only getting two results, which is the accurate information. Release date, for example, is no longer a part of the result here because it has absolutely no constraints on it. It's just a date column, right? It's not the primary key. It's not a foreign key referencing something else. And I don't really need that information when I'm looking at the constraints because it doesn't have one. So in this case, I'm able to match the information by constraint name, and I'm able to get more accurate information because the key column usage table doesn't even store the irrelevant information. It doesn't store every single column. So when I look at this, it is very, very easy for me to tell what table I'm dealing with, table name, what column I'm looking at. It's the column name that we didn't have towards the beginning of this video, right? When we got some clean results, but it was only talking about the table name. It wasn't really telling us the column name, which was a problem. That's no longer an issue. I have my column name in here. I have the constraint name. It's up to you if you want to include this information in your select statement or not. I put it in there for you to see, but as an end result, you may not necessarily need that because you already have the constraint type, but it is important for you to see that this is how we did the join. Remember how I was telling you earlier in the video that we were going to use this column for the join? We didn't do that when we were matching with the columns table because the columns table does not have this information. So we were joining on table name and table schema. But if you use the key column usage table, just like the table constraints table, you can reference the constraint name. That's why SQL creates this unique identifier, so you can do things like this. So you can run queries like this one. So that just generates a more accurate result. I left the information in here because I do want you to see that this is important and it is available to you. But, if you want a cleaner table, you can completely omit that and just like leave the other three columns in here. But here's my constraint type. At the end of the day, we said that we wanted to see column name and we wanted to see constraint type. And here it is. And all it took really is just figuring out the right join to do. And in this case, this works for me. I'm getting all the information I want. Now, one important distinction here, and this may be important. Key column usage only checks for whether or not you are dealing with a primary key, a foreign key, or a unique constraint. What it does not do is sometimes you have this constraint called check, for example, where you're checking to see that the information entered in your column is only a particular value. I have this album type column, for example, where I'm only allowing three values in there, whether it's a live album, compilation album, or a studio album. I'm not allowing a fourth entry at the moment. I may change that later on as the database expands, but currently any other value that you try to answer, you're going to get an error because that's the kind of constraint I put on that column. You're not going to get that information from key column usage. And it is just because of the way SQL stores this information. The check constraint is stored a little differently. So I will show you how you can get that information real quick, but I just won't go into detail on that one. If you're interested, let me know, and perhaps I can show you a way where you can get all this information in one table. But for right now, let me just show you quickly how you can access that information if you're interested. But just know that the key column usage table will only give you primary key, foreign key, and unique. But it will not tell you whether or not you're checking for particular values on a particular column. It's pretty simple. Like I said, I won't go into details on this one, but basically what you need to do is refer to a different table under the same metadata catalog, though. We're still within information underscore schema. I think you're starting to see you're probably starting to see why underscore schema is so important. It has so much information available to you, and you can do so many different queries with it and get some critical information about your tables before you perform any tasks. So here it is. Here's the result. My database is fairly small, so I'm only getting one result. But essentially, this is how you would get that information. All you have to do is just access it from this particular table and not the other tables that we've covered. The reason why SQL stores this a little bit differently is because the way that the check clauses are stored, is a little bit different, and they can involve some complex expressions. So SQL doesn't like to store them in the same manner as it does the other constraints, like primary foreign keys and the unique constraint. So you're not going to find this information in that other table. If you have right now, in my case, it's pretty easy to tell what column I'm referring to. It is album type. I mean, it's primarily because I'm the one who created that table, but also I'm only getting like one result, so it's easy to tell. You What you may have to do is just parse out that information. If you're getting a complex expression under this check clause column, you may need to just parse that out. This is the table that you would be referencing. Like I said, I won't go into detail. I just wanted to show you where you can get this information, and I wanted to make sure that you knew that the key column usage table won't give you this information. It will only cover primary and foreign keys as well as the unique constraint. So it's important that you keep in mind that if you're checking for this, if you're checking for the check clause, no pun intended, then this is the table that you would be referencing to. So that's it for today. I hope this was helpful. It is extremely important that we understand, especially if we're taking over somebody else's work and we're dealing with a new database that we're not necessarily familiar with. It's important to understand the relationship between the tables, and it's important to understand what columns have certain constraints on them before we perform any tasks. This is a very simple way to do that. There are a few more things to cover on this. I may do another video to show you a little bit more about primary and foreign key relationships and what you can do with the information underscore schema metadata catalog. But this video is already getting quite long, so I may do that in another one. But thank you so much for watching, and I hope to see you in another video. Thanks very much.